let's take a look at something a little bit different here. What you're seeing now is a brand new CyberPower 1500 VA uninterruptible power supply I just got a while ago. And I have it connected via a serial cable over to my Pentium 2 Xeon build, running Windows NT Workstation 4.0. Prior to Windows 2000, Windows NT did not have real native support for advanced power management or ACPI or anything like that. It was expected to be handled by the BIOS system, but it does have a service for uninterruptible power supplies, and this can be enabled or disabled in the services dialog. You can only connect a UPS through a serial port in Windows NT, obviously, and you specify the address that you specify the port that the UPS is connected to, and then what you can do here is enable a number of options. You can enable power failure signal, which is transmitted by the UPS either at a voltage of negative or positive. For my CyberPower UPS, it's negative. If you find out that you've selected the wrong option, usually Windows NT will tell you that it's unable to start the UPS service, so that you can go ahead and change it to the other option. But for here, these are all negative. The low battery signal is enabled to ensure that when the UPS reports that it is running low on battery, it will trigger the shutdown. Most UPSs have this signal equipped, but some very old ones may not. So if yours doesn't, you have this disabled, and then you specify the characteristics of the battery life of the UPS, which could be something like 35 minutes would probably be way overkill for something like this, because UPSs in the 90s were probably just honking garbage. But you specify the expected battery life. You want to make sure you undershoot this a bit to make sure that you don't screw anything up. And then the battery recharge time per minute of runtime. It's a little bit strange how that works, but basically, let's see if I can open up a calculator. If I were to expect the battery to run for 35 minutes, and the UPS says that it's expected to complete a full recharge in about 8 hours, what I do is something like this. Maybe my math's wrong on this, but I do 60 times 8 and then divide that by 35 minutes of the expected battery life. So I'd probably put down 13 minutes here. But again, you should just enable the low battery signal for most UPSs because they're very much capable of transmitting that. You can also enable the remote UPS shutdown, which is not transmitted by the UPS itself, but Windows NT tells the UPS that it is okay to switch off the power now. And in this corner, you can have the UPS service report a warning message whenever a power failure occurs. And you can have it repeat warning messages over and over again until it comes time that the system just absolutely has to be shut down. So if I go click OK and I restart the UPS service with the new settings in place, we should now go ahead and try to simulate a power failure. I set the initial warning delay to 15 seconds so that I have time to show everything at once. So let's go ahead and unplug the unit. And we now see on the screen that it is running on battery power and giving us an audible warning, and we should see a message pop up here. Just a minute. It beeps from the PC speaker, tells us that a power failure has occurred at Xeon, and advises us to terminate all activity with the server. While it shows that it's given us plenty of runtime to work with, it's better to shut down the system as soon as possible, but it will keep running until the low battery signal has been transmitted to the computer. But if I go ahead and power this on, careful not to like electrocute myself or anything. I'm not sure if that can happen with these, but you know, you can never be too careful. Saw a spark in there, and it says power has been restored at Xeon. Normal operations have been resumed. Now, I don't know what's up with his UPS, but when I was testing this earlier, it would still shut off randomly and then wait 10 seconds to turn back on. I wonder if that's going to happen again. Yeah. See, that's something I've been kind of confused about. Okay, this time I'm setting the remote UPS shutdown interface voltage to positive, since that might be the cause of it just shutting down so quickly. And we're going to go ahead and initiate another power failure, because, you know, our power system really sucks. And then we should receive a warning. And then I'm going to go back and plug this in again, just to make sure that it hasn't been screwed up. Hopefully it'll stay on. So let's wait. Yeah, I'm really just making this up as I go along here because I don't want to drain the battery twice. But having set the interface voltage for remote UPS shutdown to positive, I now see that that is what was needed because the device is still on. So let's go ahead and unplug this yet again. Hoping that it'll still stay on. See, it's still draining. Another thing with Windows NT is that once it's running on battery power, other computers can no longer connect to the system in order to ensure that, well, I suppose it should be self-explanatory. I wonder if I can ping myself as a little example. Well, I guess that works, but Perhaps if you were to connect to a shared resource from over here, it would almost certainly have to reject the connection. Okay, I'm going to be trying to be a little bit more merciless with the battery, initiating a power failure again. This time, we're going to be running Quake to really put stress on the CPU and thereby drain the battery faster. Now, isn't that such a cruel fate to suffer? Let's do it in windowed mode. So, let's go. Can I finish the first episode? There it goes. It sent the low battery signal. So, thanks for taking care of that. Man, it's really dropping fast now. Let's see if it can shut off the computer this time. I guess not. Honestly, I don't understand exactly how it works, but I think that's enough. I've done all I can to really show off the Windows NT UPS service with a modern, uninterruptible power supply. So hopefully that did something to really demonstrate this extremely obscure feature by today's standards.